All righty. So here's what we're going to do, everybody. Last topic for the last shape we have to talk about is spheres. Okay. And not only what to do volume, but for whatever reason, the state says we have to do surface area. So now the way we get these formulas, okay, is a little bit weird. In fact, we kind of go over a little bit in a normal year how to get them, but it gets kind of disjointed a little bit because you have to take some liberties that we have to assume some things are true that you might not have proven to be true in this level. Take some things from geometry to make that happen. Okay? We're not going to do that. We're just going to do some practice today. Okay? And we'll look at some other problems and that kind of thing and see what we can do. All right? So, okay? A sphere has three dimensions too, but what would be the dimension in each case for a sphere? Okay? There's a sphere on the screen. Okay? You know the radius of it. All right? The really cool thing about a sphere is that it's a radius length everywhere from the center, right? Every single particular angle that you could have, right? Yeah. Okay? So how do you get your three dimensions for a sphere? R times R times R. R cubed. Okay? That's kind of like length times width times height for a rectangular prism. Okay? The other part of this is just a factor of how that all gets factored in. So it's a little bit different for volume than also for a surface area. So just get these down here real quick. Okay? So volume is 4/3 pi r cubed. Surface area is 4 pi r squared. And you guys know that in each case r is a radius, right? So again, I can throw a diameter out. You have to know what to do. Okay? You get a diameter, what you do with that value? You divide by 2. Okay? Everybody okay with that? So now you have four formulas in play. Volume of a pyramid, volume of a cone, volume of a sphere, surface area of a sphere. That's it. Okay? That's it. There's only four formulas. Okie doke? Okay. All right. So let's try an example. All right. And again, you get your calculator, so these are to be pretty straightforward. So let's take a look at one. All right. So for the first one here, okay, find the volume of a sphere with a radius of 11 meters. Grab a picture of it. Okay. And we're going to run to two places this year. Okay, not three. Maybe we decided that two was enough. Yeah, this is one though also I need to show you how to put it in your calculator correctly. Okay? So you ensure you get the right answer. Okay? So let's take a look at how we do this. You guys got a picture of it? Okay. Again, we start by writing down the formula, correct? All right, I didn't write down the formula for this one, so I'm going to do it right here. So V equals 4/3 pi r cubed. Okay? Don't let the 4/3 distract you. We're going to break that down a little bit. Okay? So don't let that distract you. We're going to do it in parts. Okay? We're going to multiply by 4 first. We're going to divide by 3 last. Okay? We'll make it all work out. That'll be fine. So we have 4/3. What's the radius, kids? 11. Now we have to know what 11 cubed is. Okay? I believe it's 1331. I could be wrong. It's been a while. 11 times 11 times 11. 1331. How about that? Not bad for a year being removed, huh? Okay. All right. So we're going to have, now here's how I'm going to write this so I can get the fraction set up here, guys. Okay. So you might want to just convert this now. We're going to do 4, big 4, times pi times 1331. And I'm going to go ahead and divide that all by 3. Okay. Just like that right now. And that's how I'm going to break up the 4/3. Okay. Now, what's 1,331 times 4?
5,324.
Does that sound good with everybody? Any confirmation? 5,324 pi over 3. Okay? All right. Now, the unfortunate thing is that I don't think 5324 divides 3 evenly. Okay? I don't think 3 divides that evenly. So, what we need to do is just, at this point, just go to the calculator. Okay? You have enough work here. You've shown me that you know where the radius value goes. Okay? You simplify as much as you can without getting a lot of approximations. That's enough for your point for work. Now, go to the calculator and get it finished up. Okay? Let me show you what I mean. Okay? So, I'm going to bring this up so we can see the whole thing. We'll clear this out from the other day. Okay? All right, so we're going to take 5,324, okay? Divide that. You know what? We can do this all in one step on Desmos. We can just do that times pi, and then divide that by 3. And we get our final answer. Okay? That's kind of nice, right? So the nice thing about Desmos is that it'll do the order of operations for you. You don't have to tell the calculator what order to put the number to calculate the numbers. Okay? Desmos is a little bit smarter. It knows. Okay? All right, everybody get a similar number? So if you're going to do this on the calculator app, what you have to do then is you would take 5,324, then hit times pi, okay, hit equals, and then you divide by 3 and it equals again, okay, and you should get 5575.28. Are we good with that? Can we call that a finished problem? Excellent. Let's do it. Okay, so this becomes 5575.28. Oh, excuse me, meters cubed. And that's how you find the volume of a sphere. I can't make it any harder except I give you a diameter. Okay, that's all. Any questions, anybody? All right, excellent. Excellent, excellent. All right, so let's go on to another one. Okay, and I'll just stay in half screen right now so we can keep the calculator up. Okay, so why don't you guys work this one? How about if I do this? How about if I make it big so you guys can get a good screenshot of it, and then I'll go back to the calculator. How's that? All right, go to work on it, guys. See what you can do. And I'll come around and see. Go ahead and check your setup to make sure you have the right setup. Let me see it. Okay, before you start working the problem. You want me to give you a quick check? I'd be glad to give you a quick check. Monica, are you given a radius or diameter? So you have to convert that to a radius. Okay, how to do that? Make it even easy. Just take the value you give the diameter. Just think about that too. Okay. What that is.
It's nice that the calculator app actually has a cube button.
Yeah, it does have a cube button on it, doesn't it? if you're using Desmos, you have to use the exponent button for Desmos. Okay, but there's also one there for our calculator as well. Good. That's the number that goes in your formula. For R. Okay, so plug it in and then you're good to go. Okay, over here, guys. Getting organized about it? Okay. Don't forget, what were you given here, kids? The diameter. The diameter is 9. That means the radius is what? Oh, unfortunately, that's not the case. Okay, it's not 3. The radius is 4.5. Okay, 9 divided by 2. I know, we just did square roots. We tried to do square roots. Yeah. I know. I just said, don't divide by 2 and take square roots. Now I'm saying divide by 2. I know. I'm sorry. Did you just make up your mind, right? All right. When you guys have the answers, check with your group mates. Make sure you guys are on the same page and we'll discuss it together. Okay? All right, go ahead and discuss with your group mates, guys, if you guys are on the same page, okay? I'm going to get it set up over here on the screen. Okay, am I good so far, everybody? We'll work on set up here a little bit too, okay? I'll make sure everybody gets this plugged in correctly. But your radius is 4.5, right? You have to cube 4.5. That's going to be a nasty decimal, but you still need to use the exact value. Don't round that off, okay? Again, that simply is like changing 1/3 to 0.3. That's gonna give you a little less accurate answer, okay? So use the exact value when you square a cube, all right? So what's 4.5 to the third power? 91 point what, Lily? 91.125? Okay. Let's check it out here. Oh, don't round. So we're going to do 4.5 cubed. 91.125. Okay? No, don't round it. Okay? This number, only round your final answer. Okay? Other numbers you just stay in exact form if at all possible. Now, if it's a number that has a monstrosity number amount of decimal places, then yes, eventually you're going to have to round it somewhere. Okay? But we want to try to keep these numbers as exact as possible so that our answer is as exact as possible. Okay? Does that make sense? All right. So let's do it. So I'm going to go ahead and split this up. So I'm going to have 4 pi. We're going to do 91.125. We're going to divide this all by 3. Okay. So I'm going to take that number, multiply it by, hold on. Times 3. I get 273.375. Okay? So just take that answer. Oops, hold on. I got to hit enter. Sorry. Take that answer times pi, divide by 3, and you get your volume. 286.28. I see some no's. That's not good.
Yeah, I accidentally rounded that number. That gave me a whole extra 100.
Okay? Why did we not get 286.28? Let's make sure we're putting it in our calculator correctly, okay? So, again, what you need to do when you do this in your calculator, we're okay with 91.125, right? Okay, so another way you can do this is you take 91.125 times 4. Oh, you know what? I sure did. Hold on a second. We got to fix that. You're exactly right. Thanks for the catch. Sorry about that, guys. I must have put 3 in instead of put 4 in. Hold on. Let's fix it. There. Is that a better number? 381.70? That look better? Speak up, speak up, speak up, okay? If I'm making a mistake, you gotta let me know, okay? All right? If I'm looking foolish up here, okay? It's your call. It's your job to call me out on it. Charlie?
I don't know how I rounded and I got that exact number.
Okay, well, sometimes it works and sometimes it doesn't, so you gotta be careful. Okay? All right, so 381.70. Okay? And it's inches, I believe. Okay, now we're going to switch gears and we're going to look at surface area. Okay, same idea, just a different formula. That's all. All right, let's look at it. Okay, so look at it. It's even the same sphere. We're just going to do it now with surface area. Okay. It's a nicer formula because there's no fractions. Okay, what's R again on this one, guys? The radius. What is the value of the radius? 11. Okay. Am I going too fast for you guys? I can slow it down a minute if you need to catch up with me. Everybody good? All right. What's 11 squared? That's cubed. Okay, and that's for volume, Madeline. We got to do it now for square because the surface area is only 2 dimensions multiplied together. Okay, so it's r squared. Okay. That's okay. What's 11? Want to try again? What's 11 squared? 121. Very good. Okay. Multiply that by 4. What do you get? 121 times 4? 484 pi. Okay, we're going to put that in the calculator and see what we get. Okay. So we'll just get a new line here. Oops, let's just get rid of all this. Maybe if it'll let me. There we go. 484 pi. I get 1,520.53. I see a lot of knots. Are we clear with how we got that? Great. Okay, so 1,520.53. Okay, and this is surface area. Area is square unit, so it's going to be meters squared. And again, we don't. The nice thing is that you don't have to worry about the units. Okay, just give me that number. That's all I need. Okay. So you're gonna want to, if you are an avid mark detector, okay, which everybody really should be an avid mark detector by now. Okay, you need to probably mark if it's asking you to find volume, if it's asking you to find surface area. On your homework assignment for tomorrow, you only have, I think, 6 problems. But for each problem, you need to find both the volume and the surface area for each sphere. Okay? So the book only says to find the volume. I'm adding that you also need to find the surface area. Okay? So you get practice with both. Okay? All right, that's it. Okay, so should we try number 4 as a practice problem to see if you guys can get the surface area of this one? Sounds like a plan to me. Okay. All right. Again, same setup, and it's the same radius or the same diameter as before, so you guys know what to do to take care of that as a radius. Okay. And then we're going to see if we can maybe find another problem that can be a little more interesting to us. Okay. I'll start fishing around for another problem. Oh, I know one more thing we need to talk about too today. We'll try to work on that for a minute too.
I kind of remember this from last year, 4 pi r.
Okay. I'm going to get an answer real quick. You want me to check your answer, then you can check your roommates. Okay? So if you think you have the correct answer for this one, raise your hand. I'll come by and check it. Once I put it in here. All right, I got my answer. All right, you're both correct. That's the first one right in front of you. Okay? Yep. And Bill, you can catch that one too. That's not quite it there, Charlie. What's your radius?
Oh, 4.5.
Okay. There's multiply that by 4. You got 8. I don't think.
I don't think I did.
No. Get the square. You have it right. 20.25 times 4.
Oh,
I think it is 81, but then you multiply that by 5. Do it again. Yeah, times 5. Just hit the time.
that's what I did.
You gotta multiply that by 81. No. Back up here. It's all about how you put it in the calculator. So it's 20.25 times 4. Do it again. It equals times 5 equals. Boom. Okay. That's it. Charles got the answer. We'll check Tris, and Lillian can check Monica's answer. Okay. Pretty good. Don't forget your squares for it. It's a surface area problem. It's a surface area problem, not a volume problem. Okay. Just making sure you use the right formula. Okay. So, first thing I would always do is determine what formula you need. Okay? We're going to give you that for you on the assessment, so you don't have to memorize it. You just have to write it down. So we'll start by writing down your formula, first thing, with all the letters in it. Then we're going to replace letters with numbers that we have. Okay? So it's going to be 4 pi r squared. start again. Let's start all over again. Yeah, just start fresh, okay? So SA for surface area, there you go, equals 4 pi r squared. Now, you know that this is 4.5 from the previous problem, right? So 4 times pi times 4.5 squared. Okay, so put those numbers in and then go to the calculator so you can show your work on your screen, okay? So 4 pi, put the C on there. Put the C. No, that's a comma. That's the other one. Open. That's okay. There you go. 4.5 squared. There you go. Now work the problem. Okay? So 4.5 times 4.5, it equals, well, you did it just twice, it's squared. There you go. It equals times 4, well, you did it twice again. There you go. Times 4 equals times pi equals. Bingo. That's your final answer. Okay? So it's just about writing down your formula and plugging the numbers in the right place. Pardon me? 2 places. 2 places. Okay, I got one more thing to show you guys real fast. Okay? So let's get this one up here real quick. So 4 pi r squared. Remember, we're going to bring this down from the previous problem, or from 2 problems ago. Okay? So we have 4 pi times 4.5 squared. 4 pi times 20.25. This becomes 81 pi, and I believe it becomes, what was it? 245, is that right? 254. Close. Point what? 47 inches squared. Questions on volume and surface area of spheres. Same thing as Tuesday, just 2 different formulas. That's it. Okay? One more thing to show you guys real quickly. Okay? And then we're done. Okay? Hemispheres. Okay? Hey, you guys know about hemispheres, right? You studied those in social studies. Right? The Western Hemisphere, the Eastern Hemisphere, the Northern Hemisphere, the Southern Hemisphere. What's it mean for this kind of problem, though? Half a sphere. Okay? So, when you are finding the volume of a hemisphere, you pretend you're finding the volume of a sphere. Take your final answer and divide by 2. Okay? Yeah. Yeah, this year there won't be one of those. There will not be one of those on the test. Maybe next year we'll put one on. Okay? But this year, that's not going to be an issue. Okay? It has been on the past, but not this year. But I want to show that problem to you just in case. So on this one, the radius is 7, right? So it'd be 1/2 times 4/3 times pi times 7 cubed. That's how you figure out the volume of the hemisphere. Okay? But we're already close to time here. We're going to call it close today, and I think you guys have plenty of things to do tomorrow. Okay? So on Monday, we're going to try to do a half and half. So the first half, I'll try to give you a couple application problems. Okay? So we'll find the volume of something and then apply it to another, we'll extend it for a step. And then I also want to try to do a little review with you guys, make sure you guys are all on the same page. Okay? Ready to go for your test on Wednesday. But that's it. We pretty much got everything we need to cover. All right? Questions? All right, nice job. Let's get started. Say that touch, everybody, okay?